With artificial intelligence generating thousands of lines of code in seconds, what exactly does a programmer do today? For decades, the job looked a lot like laying bricks. You would patiently and carefully place complex pieces of logic together, one by one. In computer science, we call these individual bricks data structures and algorithms, or DSA. The accepted path to a high-paying tech career was straightforward. Students would spend hundreds of grueling hours drilling these isolated puzzles, memorizing how to invert a binary tree or sort massive number lists. Approaching the 2026 job market with that exact same strategy leads to a dead end. The era of getting hired strictly because you can simply solve an isolated logic puzzle on a whiteboard has passed. We have to look at the current reality. Modern AI models like Claude and Gemini can generate perfect, complex algorithmic code in a fraction of a millisecond. They are the robotic arms doing the heavy lifting. Competing purely of basic coding syntax is a losing battle. Standard algorithm generation has become a commoditized feature, losing its status as a premium human skill. Despite this shift, thousands of the brightest engineering students every single semester fall into the exact same trap. They continue to study the exact same way they did 5 years ago. That looks like a daily routine of endlessly scrolling through algorithmic puzzle platforms, searching for the optimized solution. Students still operate under the assumption that memorizing complex code inversions is the primary metric for landing a high-paying role. But this hyper-focus on the individual bricks creates a massive blind spot. By zooming in so closely on single functions, you ignore modern, large-scale software architecture. It is very similar to aggressively studying the wooden wheels and hitches of a horse-drawn carriage, while the rest of the engineering world is busy building electric cars. When a human attempts to memorize pure syntax, they are entering a direct memorization contest against artificial intelligence, and artificial intelligence has a perfect memory. Passing standardized coding tests does not equate to being a valuable engineer anymore. Modern enterprises prioritize hiring problem solvers over human calculators. Startups and enterprise companies in 2026 are looking for engineers trained in system design. This blueprint shows the architect's role, designing how distinct blocks connect. First, the backend, taking an open-source AI model and securely integrating it into a local database. Second, linking that infrastructure to a front-end application, creating a clean interface for users to interact with. When you can successfully wire those pieces together, you become incredibly valuable. The modern tech industry rewards the visionary who orchestrates the whole system, rather than the laborer who only knows how to build the isolated parts. Enterprise tech companies and rapidly growing startups are starved for system builders who can look at a holistic business problem and engineer a complete working solution. To make yourself hireable in this heavily AI-driven market, you need to transition your study habits toward a specific 3-step action plan. Step 1 is to stop at the foundations. You still need a core understanding of data structures to know how your digital bricks work. You need to know why a hash map retrieves data faster than a standard array. But spending hours on deep, rote memorization is unnecessary. Step 2 involves shifting your focus entirely toward building end-to-end systems. Stop writing isolated, single-function scripts that only accomplish one narrow task. You need to build something cohesive. For example, you could engineer a retrieval-augmented generation pipeline. Retrieval-augmented generation, or RAG, is a system architecture that allows an AI to read and reference your specific private documents to answer questions accurately. Building a custom interface that lets a user securely chat with their own PDFs is exactly what recruiters want to see. Step 3 is the absolute necessity of real-world deployment. If your project only lives on your local computer, it is invisible to the rest of the world. When a recruiter sees you monitoring performance and scaling for active users, they are looking at evidence of real-world engineering capability that a simple script cannot demonstrate. Engineering has always been about building solutions. By leaving the bricklayer mindset behind and stepping up to become a system architect, you secure your place in the modern tech industry.